Okay, let's do an example here, another friction example, climbing a tree. So we've got a tree and we have a young kid here. I guess not just too terribly young, but a kid, a school kid trying to climb the tree. So to climb the tree, what you do is you reach around the tree and you grab hold of it. So just to make it simple here, we'll assume that the coefficient of static friction between the arms of the child and the tree is 0.75. Let's say the mass of the child is going to be 31.2 kilograms. So, in order for this child to climb the tree, they have to be able to hold on to it. And so as they're climbing the tree, they get up a little ways and they stop. And so the question is, how hard do they have to be squeezing on the tree in order to stay in position? Okay, so we think about it and we say, well, in order to stay in position, free body diagram, we have the child block diagram here. We have the weight, mg. We have two frictions pushing upwards. Now, the kid is squeezing, so they're exerting a force. So there has to be equal and opposite force from the tree onto the child. So that's the normal force. And so we know that the static friction, the max it can be, is equal to mu sub s times the normal. Okay. So what we have is we have force, this equilibrium condition. So force up has to equal force down. So the force up is 2 friction forces. The force down is mg, so mg equals 2 of the static frictions. So that's 2 times mu sub s times the normal. The normal is basically how hard the kid is squeezing on the tree. Okay, so we look at that and we say the normal is equal to mg over 2 mu s. Now notice, don't make a mistake. The normal is not equal to mg. The normal is how hard the kid is squeezing or pushing onto the tree. Okay, so anyway, we plug in numbers down here and we get 204 newtons. That is the minimum squeezing force that the child has to put onto the tree in order to hold him or herself up the tree, hold in position as they're climbing the tree. Obviously, if they're trying to accelerate upwards, it has to be more than that. And so just thought this would be an interesting extra example for friction.